Hi everyone, and welcome here to this review and introduction of an article by Agalos Kayas and Philip Lazos, two prominent researchers at IOHK. Came out the 18th of January 2022, and at the time of this recording, it's 4 days ago since it came out, so quite recent and can be very relevant to the Cardano community. I have a title here, the ADAO Academy series. This is just a placeholder. We're not sure if this is what it's going to be called, but we want to do some kind of education about DAOs and share knowledge that others have created and that we also over time will accumulate. So my name is Robert Isaacson, and I'm one of the core contributors at ADAO, and very interested in education and research on this topic. So the article is built on 7 properties of blockchain governance, and these 7 properties are based on the author's review of the literature or some of the literature, and claim that they have a comprehensive array of properties for sound governance systems based on this. I'll get back to this at the very end, but here's a list of 7 properties, and there's a lot to learn here. So we're going to focus on each of these in step. Confidentiality, verifiability, Pareto efficiency, accountability, sustainability, liveness, and suffrage. And we'll go through each of these and explain what they are with examples taken from the paper. So the first property is confidentiality, which is kind of self-explanatory, but the authors break this down into 3 different types of confidentiality. Secrecy, they mention first, which is that other people in the network won't know how you have voted, basically. And they point out that often, quoting here, often true secrecy is difficult to accomplish in a decentralized setting or might be undesirable. And we'll get back to that on the next slide. So that's secrecy. Being able to be pseudonymous means that either it's on-chain or in a chat room, you can be pseudonymous. There's still some kind of online identity, but it's not connected to real-world identity. And this is often where blockchain governance is found, being in the pseudonymous. Coercion resistance requires secrecy, and it's a kind of step beyond secrecy. So not only that other people don't know how you voted, they don't even know if you voted or not. And this means that you can basically trick. So if somebody's trying to coerce you to vote, you can make it look like you have voted when in fact you haven't, or vice versa. The next property is verifiability, which means that we can verify that the vote has been tallied up in the correct way. And the authors provide 2 subsets here. Individual verifiability, which means that, as an individual, we can verify that our vote has been tallied correctly. And then universal verifiability, which is that everybody can make sure that everybody's votes have been tallied correctly. And this verifiability and the one we had previously, confidentiality and especially secrecy, there might be might be difficult to do both perfectly, and there are possibility of different ways of having both, for example, secrecy and universal verifiability, but there might sometimes also be a trade-off. Okay, here we come to the first property, which has a rather technical term. And so I'll just read a quote from Investopedia talking about this. So it says, Pareto efficiency or Pareto optimality is an economic state where resources cannot be reallocated to make one individual better off without making at least one individual worse off. Pareto efficiency implies that resources are allocated in the most economically efficient manner, but does not imply equality or fairness. So it just means that in a system, for example, a DAO or a blockchain, that it's one that maximizes everybody's utility. And if you give more utility to one person, that shouldn't make it worse for somebody else. If you do, then it's not Pareto efficient choice. And it also says a point here on Investopedia. Pure Pareto efficiency exists only in theory, though the economy can move toward Pareto efficiency. So there's not an absolute, yep, this is perfectly Pareto efficient in each choice, but we can try to move towards that for it to be as economically and as effective as possible. In the paper, the authors mention these 5 different approaches to voting to try to reach some kind of Pareto efficiency. And the binary choice is the quite common one, which is there's a proposal and you say yes or no. And they have an example here when discussing compound about some of the issues with this kind of yes-no voting. So I'll read that here. Once a proposal enters the voting phase, the voters only have 2 options, yes or no. This is clearly Pareto efficient and aligned with their incentives. Things get more tricky once there are multiple incompatible options. In this case, the proposals would have to be dealt with sequentially, and the actual order could bias voters, which complicates their decisions and leaks information. Therefore, Pareto efficiency is somewhat satisfied. For example, between 2 highly popular proposals, the slightly less popular one might win if it is up for election first, and then the users might be less eager to implement another change. So say there's 2 options coming up, and the one just happens to be before the other one with your voting, then people might choose to just vote yes, because it's an improvement based on what we have currently, but the second option would actually be even better, but by that time we've made a decision, so we're just going to say no. And that's not Pareto efficient. We have the yes-no past, and we recognize that from Project Catalyst, and where they mention some of the issues here that we recognize. So I'll read here as well. There is an incentive for each voter to submit an uninformative no vote to many proposals in order to maximize the winning chance of their favorites. So say you have a project that you want to get funded, then it's incentivized to do a no vote on other competing projects who are competing for the same pot of money. And then the author is going to talk about there's things that we can do about this, like ordinal voting, which means that instead of having a yes-no pass, you have, for example, say there's 10 projects, and then you can say, yep, this project I put as my number 1 vote, this project is number 2, and then so on down to number 10. That could perhaps be something we could do to fix this issue. A problem with that is, say there's 10 projects on Project Catalyst, or 10 different competing suggestions about how to change the DAO or a blockchain, and suggestions 2 to 10, for example, yeah, they're fine. I don't really have an opinion. I'm fine with any of those, but I really care about number 1. And in the ordinal voting, I can't demonstrate that. But with cardinal voting, I can. So I could, for example, put all of my ADAO or my governance token to this proposal. A problem with cardinal voting is it can quickly turn into an auction, that the ones with the most tokens automatically win. Something that can be done with that, which the authors mentioned briefly, but isn't their focus of their paper, is something called quadratic voting, which means that for a greater amount of votes, you have to put in a exponentially higher amount of tokens. So, for example, if you want to have a vote, and I want to put forward kind of like, yep, 1 one vote for this, it could be one token. To put forward 2 votes, it wouldn't be 2 tokens, but it would be 4 tokens. And if I want to put forward 3 votes, it would have to be 9 tokens, and so on. So that's kind of an approach to try to deal with this auctioning off votes. This assumes, of course, that we can know that people only have one wallet, so that's a question mark there. Another possibility is something called token locking, which means that to demonstrate how important it is to you, you can lock your token for shorter or longer periods of time. And this actually brings us on to the next property. So the accountability property basically means that those who vote are as directly affected by that vote as possible. So for example, if you have some decision to make and you vote with your tokens, do a snapshot, and then the actual implementation of that occurs later, you're not really accountable because you could, in between that time, sell your tokens. And so the paragon, like the great example in this paper is Polkadot, where it's that you have to you lock your tokens and you vote for some project, and then you can't unlock those tokens until the change has been implemented. So that's kind of accountability, and most of the projects don't have much of this. The authors say Bitcoin do a bit and Project Catalyst do a bit, but Polkadot with their token locking mechanism are the perfect example. So now we come to sustainability, and there's 2 subsections here: sustainable development and sustainable participation. And in my mind, the authors take quite a narrow view here, and it's so, for example, saying that Bitcoin and Ethereum have neither sustainable development or sustainable participation. But so, for example, Project Catalyst does, because in Project Catalyst, people are incentivized through being rewarded with ADA for participating over a certain amount of ADA, and also with development. You submit some proposal, and then you have the chance of being funded. I would say that there's other ways to other utilities than purely monetary to do development and participation. Ideology, vision for the project, things like that. So I think the authors are a little bit too economically focused here, but I guess I get where they're going. So to think about how do we incentivize people could be the broader question to suggest development improvements and to participate in voting. Those are kind of broad questions to think about. And one way is by giving tokens, and there can be other ways as well. So liveness is an interesting property. It has to do with how quickly can the protocol or blockchain react to an internal or external threat. So say there's been found some issues with the code, or there's been a breach of the code, or there are some external market factors that are cause an existential threat to the protocol. How quickly can we react to this? And with some protocols or blockchains, there's this long drawn-out process to make sure that we have a proper deliberation and that there's no funny business going on. And where traditionally it might be thought that centralized entities, for example, democracy is usually thought of as perhaps a bit slower than a company where you have a CEO who can just make changes on the fly. And so you experience some of the same things potentially in the blockchain space. MakerDAO, I think, have found a good, not even a compromise, but a good way out. which is explained in the paper. And so there's this discussion forums where people can discuss ideas back and forth, and people are actively invited to contribute there. And then that can be taken up to an on-chain voting, an on-chain vote, and then there's a final vote as well. So that's kind of the long route, the deliberative. There's also possible to create what's called I'll read here. An executive vote can be implemented in 24 hours once it receives enough votes. This gives both the ability to quickly prevent a bad proposal and relatively quickly enact a better one. In addition, there is also an emergency shutdown functionality. Therefore, Liveness is satisfied. So whether there's like, okay, we have this threat, let's put up this proposal, get votes going, and we can implement it. At the same time, there's this opposite side, which is if even one person says, no, this isn't what we should do, they can put in a lot of the maker tokens and shut down the process so that things, there isn't this single centralizing force forcing things through. So that's liveness. The final property is suffrage, and this is basically saying on what criteria do people provide votes. And the first one here is identity, and we know this from elections. You know, one person, one vote. It's a bit more difficult in the blockchain space. So there, you know, the authors of course mention things like DIDs, decentralized identities, and the possibility of that. One of the most common is tokens, whether that's on blockchains like Cardano, where it's proof of stake, or whether they're DAOs or protocols with their own tokens. Then there's mining power, like on Ethereum, Bitcoin, Ergo. Meritocratic, which brings in an interesting element. So basically, it's like, for example, with tokens, we've had this discussion in Cardano many times. The people with the most tokens currently have a lot of voting power because that's what it's based on. It's based on skin in the game. But what about other things like the merit or the value that we otherwise provide to the blockchain? The question, of course, is who is included within the meritocracy? Don't know how to say that. So basically, who's included as providing value? And usually it would be, so for example, in Ethereum and Bitcoin, there's a core group of developers who over time have shown that they've contributed and have been chosen by others in meritocratic positions that they can be included. And this is also somewhat similar in DAOs in many cases, where there's perhaps a core group who have some kind of ideas about what it means to have a meritocratic role. But there's definitely questions to be had there. And universal relates to what we've heard Charles talk about, basically including all of these identity, tokens, mining power, meritocracy. There we go. There, I found it. And meritocracy could be many things like education and marketing and developing a platform and anything that provides value to the blockchain or to the protocol. And so the universal is there kind of incorporating all of these things. And exactly how to do that, how to weigh those different, tokens versus mining power. How do you do that, for example? And there are some examples of blockchains doing this, but that's also a discussion to be had. So the paper provides some very good thoughts about properties of blockchain governance, and now some critical comments as would be required in regards to any academic paper. So the first point is methodology, and the authors start by saying that they want to have this comprehensive view. And my question when reading was, do they really have the methodology to support this? And basically what they do is they say, here I'll quote, our methodology is first to derive a set of properties that are drawn from general governance principles and election theory, and then interpret them to the blockchain governance setting. We use a variety of sources to ensure the comprehensiveness of our property list that include, and then I talk about 1, 2, 3, 4, 5, 6 different standards and things like this. Are we sure that's comprehensive enough? So compare this to the other paper that we've looked at, which is Blockchain Governance, a Dynamic View by Latikainen, Lee, and Abrahamson, who show clearly their methodology. They set out some criteria for this is what we will include, this is what we won't include, these are the reasons why, and then they show the process of how they go through their exclusion criteria and how they end up with the papers they end up with. In addition, the Latikainen and colleagues paper is peer-reviewed. The one by Agalos Kiasis and Philip Lazos is not, as far as I can tell. They have some colleagues who have helped them a little bit, but it hasn't gone through peer review. And also the Latikainen and colleagues paper included practitioners, which isn't necessarily necessary for an academic paper, but it does make it, there's a practical experience and knowledge which comes with talking to practitioners, which you don't get from a purely theoretical approach in many cases. So that's kind of that insecurity about, is this really comprehensive? There's a lot of good thoughts here that we can learn from, but is it really, are we sure that it's comprehensive? So there's a couple of important exclusions for practitioners, and the authors do point out that they're talking about general properties and not about unique mechanisms. For example, quadratic voting, they only mention in passing because that's not central properties, but relevant for us to think about. So for example, suffrage can be through tokens or through merit, but there's a lot of protocols, platforms out there where you get tokens through merit, and especially on DAOs, you know, there's some bounty put out and then you can get some tokens in that way. This isn't discussed in the paper. Initial tokenomics, very essential to discussion about governance. And even if you're not going to talk about, you're only going to talk about the high level properties, I found discussion or lack of discussion or even mention of tokenomics surprising, to say the least. And then inclusivity, which is mentioned in parts. So for example, how many tokens do you have to participate in voting? And so on Compound, you have to have $15,000 worth of the comp tokens. On Dash, you have to have $100,000 worth. So it's, yeah, very high. Catalyst, and this is where the authors say, you know, only, and they use that kind of word to kind of show that, you know, Catalyst is much lower than the others, but it's still about $500 to $600 worth. Does this include, is this, can we then include everybody on our planet? And of course, there's a trade-off here between skin in the game versus inclusivity, but this is also not discussed in the paper. And there's minor details, like they have very good, let me find it here. very good figure on page 8 out of the 18 pages, rather table, sorry, a table. And there's a few things missing. So for example, that Catalyst, in the text it says that Catalyst does have sustainable participation, but in the table here it shows that it doesn't. So minor things like that that can be worked on. But anyway, yeah, very good and interesting paper for everyone who's interested in blockchain governance, and hope this video could be some use into getting an idea of what this paper is about and what it can offer us.